Okay, so what we would be covering for today is, today we will be taking a step ahead and we will be covering Hadoop 2.x architecture. Okay, so that is what we would be covering today. Hadoop 2.x architecture, that is the first alignment. Once we finish this, then we'll try to understand our Ubuntu VM. Okay, so the machine which we have prepared for our practice, we'll try to understand that what are the ecosystems involved, okay, how to connect, and whenever I would be sharing you this virtual image, how you have to install, and the will be there. It will be just a matter of 2 to 5 minutes, not much. Then we'll try to cover all the HDFS commands which are there. Okay, so if you know Linux basic commands, so HDFS commands should not be a concern for you. Okay, so this is like what is aligned for today, and we'll try to complete that within the time frame. So let's start with Hadoop 2.x architecture. Okay, so in Hadoop 2.x architecture, first let me just draw some blocks which are needed for us to understand. Okay, so I'll go with the same flow of yesterday, like, so the client, the request would be coming from client. Okay, so there will be a node, that will be a master node. Okay, so in that we'll be having your active name node, and we'll be having a standby name node, then we'll be having a secondary name nodes. Okay, so I'll just give me some moment. So I'll just quickly draw these chunks and we'll start with the explanation. I was planning to keep this ready, but I thought let's draw in front of you. Okay, so let's write few things. So like yesterday, so there was a client, or there was a person, someone like edge node. Okay, if we recall yesterday, we had a person called, and that person was nothing but name node. Okay, but today there's one more person which has been introduced in the second 2x architecture, that is nothing but standby. Okay, standby, I will write a short form, name node. Okay, and we already have person that was nothing but secondary name node. Okay, we already have these people. We already have data nodes. So let's say this is data node 1. Then we had data node 2. So I'm just taking not much diagrams, so that just keeping simple and straight. Okay, let's start with the explanation. Few blocks I have drawn. So we'll come to know what are those blocks and what they mean for us. But again, like 60 to 70% will be like of yesterday's only. Okay, cool. Let's start. So the first thing what we will start with is, we all know, okay, yesterday we have seen Hadoop 1.x architecture. So in that architecture, what we have seen is the block size was 64 MB. Okay, so when it comes to Hadoop 2.x, okay, so the block size has been increased to 128 MB. Okay, sorry, there's a typo. So first difference we are seeing over here. Then when it comes to replication factor, so the replication factor is as is, so it's 3. So there is no change. Okay, so the first thing is, what we are trying to see is the block size is 128 MB, whereas the replication factor is 3. Okay, let's take the same scenario of yesterday. A file is being processed, or file is being submitted from the edge node to the master node. Okay, so let's say we are having a file, and let's say we are having a file of, let's say, 200 MB. Okay, so if I say I'm having a file of 200 MB, okay, so I will be having one. So let me just erase this. So let's say there is one chunk of sum, and there is another chunk of sum. So the first chunk will be of how many MB?
128.
128 MB. Beautiful. And what will be the second chunk? Remaining, whatever it is. So it could be like 64, I guess. Okay. So are we able to understand, like, this, when we are getting a file of 200 MB, so it is getting broken into two chunks. Why? Two blocks to be precise. Why it is getting broken into two blocks because the default block size in Hadoop 2.x is 128 MB. So 128 MB, so the first block out of my 200 MB, 128 MB block is available over here, and the remaining
72.
72, it should not have been 64, so I just said, okay, so it should have been 72. Are we good till here? So we are getting two blocks from my 200 MB file. Okay, that is what we have seen yesterday. So now, if you remember yesterday, just 1 minute. Okay, so this is a recall of yesterday. So what we, please be on mute. Someone is not on mute, so let me not. Let's recall. So okay, so if people were available in Hadoop 1.x architecture, so this is an extension to that. Okay, so what we are trying to do, we are trying to understand what is there for us in Hadoop 2.x architecture. Okay, so the first change what we saw is on Hadoop 2.x, so the block size is 128 MB. Yes, in Hadoop 1.x it was 64 MB. Okay, so then what we have seen yesterday, so we had a replication factor of 3, so here also we have a replication factor of 3. Now let's say we are getting a file of 200 MB. So this file of 200 MB is getting broken into two chunks. Okay, so as like someone said, so the first chunk will be like 128 MB, that's what we have seen, so 128 MB chunk, and the other is 72 MB, right? Now what is happening is when the request is being sent from the client to the master node, okay, so whenever the request is sent from the client to the master node, we all know what name node does. The name node works, or name node's responsibility is to manage the cluster or to manage the metadata, okay, and the cluster, whatever the health is. So when the request is coming, again we have seen yesterday, so we have a person, that person is called fs image. Okay, so let me quickly copy this, let me paste this over here itself and here also. That's what we have seen yesterday, right? So when a request is coming, what name node is doing, it is gathering some metadata. Based on that, it is deciding that my data needs to go to data nodes. Okay, so what they would be doing is, name node will be having the information to which data node the blocks are written, okay, what is the location, which data node is having what blocks, and so on. That's what we have seen yesterday. Before proceeding to that, again we have seen one more important pointer, and the first important pointer was, we have seen that blocks are written in parallel. That's what we have seen, the first concept, right? So what do I mean by this is, so this file which we are getting of size 200 MB, which was broken into two blocks, so this is the first block which is getting somewhere written over here. Okay, so let's say I'm just making it a little smaller because it won't fit. Now again the remaining 72 MB, so this is also coming, and let's say this is getting written over here. Okay, so these two blocks were written in parallel, and the later on what we have seen is, okay, and the later on what we have seen is that, just give me 1 second. So what we have seen is blocks are written parallel, and the second concept what we have seen yesterday is replication is happening in sequential, right? That's what we have seen. So once the blocks are written successfully, okay, so once the blocks are written successfully, okay, the sequential start happening. So this will be replicated over here, this would be replicated over here, okay, and similarly this would be replicated over here, and this replicated over here, correct? That's what we have seen yesterday, right? So let's do that quickly. So let's quickly do copy paste and bring this over here. Let's copy paste. So the replication is happening. Let's copy paste this as well. So let's say this is over here and this is over here. Okay, so the blocks are written parallel, replication is happening in sequential, done. If you remember yesterday, these data nodes were sending the heartbeat to the name node, right? So today also they are sending the heartbeat, not today, in 2x architecture. Okay, so what these people are doing, data nodes are sending heartbeat. Whom they are sending to heartbeat after every
3 seconds.
3 seconds they are trying to send the heartbeat. Okay, same like yesterday. Okay, now there is one more addition today. What is that addition? The data nodes which are sending the heartbeat to your name node, they are connected to your standby name node also. What they are connected to your standby name node also. Okay, just remember the word connected. Will come at a later stage and we'll understand how they are getting switched instantly when the failover happens. Okay, so that is the extra addition today what we added. So the block size got changed, first change. The second change is the data nodes are also getting connected to my standby name node. Okay, cool. So far so good. Now let's take a yesterday's example. Okay, so if we take your yesterday's example, there was like Satyajit like was the team leader and there were 3 people reporting to him. Okay, so like we had Satyajit over here, then we have Saif over here, and then we have Obed over here, and then we had Krishna over here. So this is what we had taken example yesterday. Okay, now if you just take or just try to understand, if this like yesterday's failover mechanism, if this was failing, so again the data was picked from here and it was like the image was created again because it had a failover mechanism. So that was it. But in 2.x architecture, so what is happening is whatever your name nodes are there, they are also being monitored by someone. Okay, they are also monitored by someone. And before that, if one more thing like yesterday we had, and that was, let me add that first. So if you remember, we had edit logs also, right? Yesterday we have seen that. So we had fs image and edit logs. Now where these edit logs are there, now this edit logs is at a place, and that place is called journal node. Okay, so I'm just writing short form, or let's in place of let's write it full form so that it's, so this is nothing but journal node. Okay, now don't get confused between, now see, name node, standby name node, secondary name node, data nodes, and so on. All these are physical machine of commodity physical machine. Okay, so it's not that I'm keeping everything at a central place. So as I discussed a terminology or a jargon, cluster is a group of machines. So you can term that this is one machine, this is one machine, this is one machine, and this is one machine, and so on. Okay, so there is a edit logs. We also remember, or we should be able to recall, what is my fs, what does fs image has and what does edit logs have. Okay, so they have a pointers to your metadata which name node preserves, and belonging to whom? Belonging to data node. That's what we have seen yesterday, right? Now in this 2.x architecture as comparison to 1.x architecture, so there is a third change is there. If you see yesterday, these edit logs were part of your name node, right? But now they are sitting in a different machine or a different node. So what happens is, whenever the request comes to the master node, what name node does is internally it writes the pointer to the fs image, as well as it will write the pointers to the edit log, right? That's what we have seen yesterday, correct? So it is writing it. Okay, And at the same time, what the secondary name node is doing is, from this edit logs, it is trying to update its fs image instantaneously. So what this is doing, this is trying to read. Okay, what it is trying to do, it is trying to read. Yesterday, what we have seen the concept. So after every 1 hour, okay, what was happening? After every 1 hour, these edit logs were going to the fs image. In the in the secondary name node, there was one fs image. This fs image and the newly edit logs which was coming. So this is nothing but edit logs. So together, what was happening? There was a process, and that process was named as checkpointing, if you remember yesterday's concept. Okay, so what was that concept called? Checkpointing. Here also we have the same concept, no difference. Okay, so after every 1 hour or 1 million transactions, the edit logs will be sent. Okay, and the checkpointing process will happen. So we know that also. But the difference over here is, there is one name node and there is one standby name node. Whenever the request comes to the name node, internally it writes the data to fs image and edit logs at the same time. We need to understand this important point. At the same time, from this edit logs, what standby name node does is, it keeps updating its fs image. So at any given point of time, this fs image and this fs image are in sync. Okay, at any given point of time, this fs image and this fs image, they are in sync. So that is again a one change. Okay, cool. So almost like yesterday's, but few additions. Now, as I was discussing earlier, so there are two people like name node and standby name node. So there should be a person to monitor this. So here comes a manager. So let's say this is like yesterday there was a Satyajit who was a team leader, but now today there is one person who will be a manager, and that manager is nothing but zookeeper. Who is that manager? The manager is nothing but a zookeeper. What his work is, to manage the name nodes, to monitor the health checks or health status of name node. Okay, so this zookeeper will be monitoring this name node. Even this zookeeper will be monitoring this name node. Now, how this zookeeper will come to know whether this person is an active person or this person is a standby person? And at the same time, how my data nodes will come to know, should I report to this person or should I report to this person? Again, that will be a conflict, right? So to make that happen or to handle that in the architecture, what happens is, the zookeeper has a mechanism, and that mechanism is called, and again it's a Java program which we do not need to worry about. So there's a mechanism of a Java program that is called failover controller. What it is called? Failover controller. So here also we will be having a failover controller. So zookeeper would be deciding whether this is active or this would be active. Now how zookeeper would be deciding? By assigning certain properties to failover controller. What zookeeper will do? Zookeeper will try to assign certain property to this failover controller, and that property, for our understanding purpose, is nothing but, let's understand this is an active. Okay, now how it will come to know, or let's say how zookeeper has identified that this is my active failover controller mechanism, and this is my standby failover control mechanism with the help of a log file, and that log file name is nothing but in underscore use log file. What is that file called? In underscore use log file. So what Zookeeper will be doing is Zookeeper will be assigning, with the help of a Java program, it will be assigning a file or a log in underscore use dot log to any name node, and that name node becomes your active name node. Okay, so whichever file has in underscore use log, the data node sends the heartbeat to that name node only. They do not send the heartbeat to other name node. Okay, cool. So far so good. So let's do a small recap. So we have a 128 MB block size. We have three replication factor as 3, right? So today we took a file of 200 MB which got broken into two chunks. One is 128 MB and the other is 72 MB, right? We have
Hi,
seen,
sir.
we have
Hi,
seen
sir. Unlock this side. Like, who is basically breaking this file into two chunks?
who is breaking this file into two chunks. Internally it is broken into two files. As soon as the threshold is reached of 128 MB, it immediately breaks and writes to a new chunk.
So it is happening over edge node or in name node?
It will be happening internal of your Hadoop cluster. Nothing will be happening on your edge node. Okay, so nothing
Oh,
will be happening on your edge node. Everything will be happening on your cluster, and that cluster is your Hadoop cluster. Okay,
okay.
yeah. So we were seeing blocks are written in parallel, which means that 128 MB and 72 two blocks were written in parallel. As soon as they were written, it got replicated to 3. Okay, then afterwards, like yesterday, we had a concept of name node, fs image, and edit logs. Okay, in addition, today we got a standby name node and fs image. So as soon as the request is coming from my client to the master, what name node is doing, it is maintaining the metadata. Internally it is writing the fs image, and as well as it is writing the edit logs, right? So at the same time, when my edit logs are written, the secondary name node, the standby name node which is available, immediately it is reading and updating its fs image. So at any given point of time, both the fs image are in sync. Okay, we have a standby name node. Okay, it has an fs image. After every 1 hour, 1 million transactions, so the edit logs are being sent. Okay, again there is a process, and that process is called a checkpointing process. Cool. What if now, as we have two name nodes, one is active and one is standby, how will I come to know which is active and one is standby?
Saif
So
Arif here.
just wait
Sorry
a
to
minute,
interrupt.
let me finish and I'll come to the questions. Okay, I'm just giving a small recap. So what this Zookeeper will do, Zookeeper will have a Java program. With the help of Java program failover control mechanism, it will have a in underscore use dot log file. It will assign that in underscore use log file, and it will make that name node as an active name node. So whoever is having that please be on mute. So whoever is having in underscore use dot log file, the data nodes are reporting to that name node after every 3 seconds. Okay, and Zookeeper is continuously monitoring these two name nodes, so that even if one name node goes down, again I will come to that failure mechanism. Yeah, so yeah, Arif, you were asking questions, sorry.
So we have standby node and secondary name node, right?
Standby
Anyway,
name node and secondary name node, yes,
anyway, the data will be synced between name node and standby name node. But
right.
why do we have a secondary name node here?
Correct. That's a good point. And so what Hadoop did is, okay, because as it was available in Hadoop 1.x architecture, so they just carried the feature in Hadoop 2.x architecture. So they didn't wanted to erase that and just to keep as is. So if you take an example of a mobile, okay, so let's take an example of a mobile which has a Nokia. Okay, so nowadays, not Nokia, let's say Redmi Note 5 and Redmi Note 6 today. So whatever feature Redmi Note 5 had, so it has been carried over to Redmi Note 6. In a similar fashion, that has also been carried over here. Got it?
Okay. So why do we use Zookeeper instead of, we have so many tools like Ambari and all. Here, why do we have Zookeeper?
See, Zookeeper is like, again, like we need to understand Zookeeper because I haven't explained that. So Zookeeper is like mainly like for monitoring the monitoring and keeping the health checks. Even if you go for Kafka, even if you go for HBase, so Zookeeper is the person who is specifically designed to monitor and to keep the health checks active, and all those things are there. So for that purpose, in this 2.x architecture, they adopted Zookeeper.
So do we need only to use Zookeeper or any other monitoring tools?
You can use any monitoring tools, and as a developer, it's this is not our responsibility. Okay, so when it comes to this cluster configuration and cluster creation, this is like an Hadoop admin's responsibility. Okay, but as of now, it's not like, okay, you need to use Ambari or you need to use Zookeeper. Whatever monitoring tools are available, you can make use of that. No restrictions.
Okay, so we have 200 MB of data, right? And it's getting divided into two blocks, 128 and 72. So suppose if we are adding another 100 MB, right, the remaining space which is available in second block will get appended, or new blocks will get created.
So the new, see, what will happen is 128 and 72. Okay, so the, let's say if 100 MB file is coming, right? So again, it will be broken into two files. Sorry, it will be only one file, correct? Because it is less than like your 128 MB block. Okay. So what will happen is, so it will just start writing from that. Okay, and it will start getting that. So let's build like this, and whatever the next piece will start. So it will be written like this. Okay, so internally it will, I know what you are talking about the in terms of storage. So will I be not making use of the remaining, like out of my 128 MB, will I be losing that? So internally it's very compact, and there will be no like wastage of your storage. So it will start writing from that point. But again, this will combination will be of like your 100 MB file or the new file which came as a request. Same like yesterday, what we have said.
Okay, so we have name node and standby name node. What happens if the link got broken for standby name node?
What happens, so I have not come to the failover scenario, so I need to explain those.
Okay,
Yeah, so we
thank
need
you.
to catch that. So once that, we can again take question answers.
Yeah, thanks.
I will come back.
Sir,
Yeah,
what would be the allocation if we have a file size of, let's say, 300 MB or 400 MB?
let's take a file size of 500 MB. Okay,
Okay, okay,
so 500 MB, so when the file size is coming of 500 MB, so if we just take, sorry, so 500 MB divided by 128 MB, how many blocks are getting? 4. So let's say
4.
3 will be like 128, and whatever the remaining will be something. Okay, so
Mhm.
what will happen, so 1, 2, 3 blocks, and whatever, let's say the remaining block, so fourth block will come over here.
Okay,
That's how the see, as of now I am taking a very small architecture just for an explanation purpose. But
Mhm.
when it comes to industry or the projects, the clusters would be very huge. In the sense, like, it means again, in my project, so we have a cluster size of 63 node cluster. Okay, so it depends from project to project and industry to industry. So for explanation, I'm just taking 3 nodes over here. Okay, one standby, one active. So again, like, based on application to application, this design would change. So I'm just giving you an idea how your Hadoop cluster would look like.
uh, okay.
Okay,
Sir, two more questions. Zookeeper, edit, journal notes. These two are also our machines, correct? Different
yes,
machines.
everything is seen in a cluster. It can be a scenario, this name node and this edit logs can be installed on the same machine or different
Okay,
machine, which
okay,
means that it can be installed on the same node or a different node also. Again, that is like based on like what is your cluster size, what is the requirement. All those things will be taken care by the Hadoop admin people. We
okay.
are nowhere involved in there.
Okay. And my second question is,
Mhm.
uh, will the configuration of all these machines would be same or
No,
like?
no, no, no. The configurations of each and every machine will be the same because data nodes are the be on mute once you ask the question.
Yeah,
So data nodes are the people, okay, who will be doing the computation, means who will be doing the work. These are your slave processors, right? So they
yeah,
will be having again like they should have a very good storage capacity and well as processing uh, capacity as well. When it comes to name node, it will be just storing the metadata. Okay, it will not be doing the computation process. So all those configuration are being taken care, and every node, which is nothing but a machine, has a different configuration.
okay. And there is still chances of this entire system to get fail if my zookeeper or edit general node gets fail, correct?
Yes,
There will be no
there are
clone.
always failure scenarios are always there. But again,
Okay,
I'm just taking an example of zookeeper. But in projects, what happens is they create multiple zookeeper. I have taken one edit logs. So based on your cluster size, they'll create multiple edit logs. So I've taken one name node and one standby name node. Based on your cluster, they might be creating multiple name nodes and multiple standby name nodes. Giving so let's say in an account. So let's say there are like one account is one big data project is serving to HDFC Bank, other is HSBC Bank, other is IDFC Bank. So they would be creating cluster, means internally they would be creating namespace for HDFC Bank. Again, one more name node will be for HSBC Bank. So again, like internal they would be doing. So this is like a very high level overview which I'm designing or showing for one application or for one account or for one project, you can say, to just to
got
get
it.
an understanding.
Got it.
Yeah,
Thank
yeah.
you.
Saf, one question, Amish here.
Yes, Anmish.
So like if one of the block size is having suppose very small amount of data, there is a file of 131 MB.
Right.
So in one block it will go 3 MB. So another data comes. So will it be utilizing that remaining space or it will go to next block actually?
That's what Arif asked the question, right? So if the question, so let's say we are getting a file of let's say 130 MB, right?
Mm-hmm.
So the block size is 128, right? So let's say 128. Let's take this 128 MB is written. So immediately from here, like 2 MB would be written. So that will be a second block, huh? Not the same block. We need to understand that. So there is, I know like what you are thinking in terms of like will be like missing the storage, or this block would be separate and that block would be separate. So internally it is stored like in a sequential manner, but that is a chunk of like 128 MB blocks. That's what we need to understand.
So in total it will be like so if a new file comes, right? So it won't be going to different block. It will be starting from that block.
See, now
Yeah.
let's take one more file is coming. Okay,
Yeah.
100 MB.
Mm-hmm.
Is it like it's like less than this block, right?
Yeah.
Okay, now name node will decide which data node is having less work, again because it manages the cluster and manages the metadata. Okay, so it came to know like, okay, so this is like again it is starting, it always start from the nearest one. Okay, that's how your name node decides to allocate the work, and from the nearest one to the largest one, based on the available load, it tries to allocate the new work which is being received from the client. Okay, so now if we are getting an 100 MB file, what will happen is, so this 100 MB file, okay, it will start immediately writing. Okay, so now it will be like this. Okay, so let's say 72, so let's say 128 minus 72 plus, okay, let me just, so let's say 72, let's say plus 50, something kind of, this will become 128. Okay, but again the remaining part will be written like this. But
Okay.
entirely this is like from my one file, right?
Yeah.
Yeah,
One
so
point.
yeah, so this is how your sequential data would be written in blocks. Because what happens is when the data is being sent for processing, it is being sent in the block in the form of 128 MB chunks. Otherwise,
Mhm.
we will have issues of small file problems, which we will see
Yeah.
that interview questions are there. So small file problems.
Yeah. Okay. Thank you.
Seth,
Yeah.
yeah, Vijay this side.
Yes, Vijay.
Yeah, actually, we discussed about Hadoop 1.x yesterday. I
Okay,
mean, we have this job tracker and task tracker in
right,
Node.
right, right.
So similarly, do we have?
Yes. That is taken care a little later. So in Hadoop 2.x architecture, so if you remember yesterday, I have written one point. Okay, so job tracker was not able to manage resources outside Hadoop, right? If you remember, if you recall, I have written 3 4 pointers. So the first was single point of failure, right? Right? Hello.
Yeah,
The
yeah,
second point was like scalability. Okay, the third point was like job tracker. Okay, so wherein like job tracker, it was managing everything. Okay, and hence it was not able to manage whatever resources which are being outside of Hadoop. But here there is an introduction of yarn, which is nothing but yet another resource negotiator. So job tracker got replaced with resource manager, and task tracker got replaced with node manager. So I will be taking one separate topic on yarn. Got it?
yeah, yeah, sir. Thanks.
Yes. Okay, so let's make a move. Okay, hopefully like whatever the topics which we covered, so we are just syncing and making a little forward. Okay, now what Zookeeper is doing is with the Java program, it is assigning a in underscore use.log file, and that name node, the heartbeat is being sent by the data nodes to that name node. Okay, that is what it is happening over here. The edit logs are written immediately, and the standby name node is immediately updating its FS image. Okay, and the same process of secondary name node is nothing but the checkpointing that is happening again. Now, what happens is yesterday's scenario, if we recall, so there was a failure scenario which we have seen. So let's say at certain point, if my name node, if my due to some reason, if my cluster is going down, okay, at that moment of time, I was having some data loss. Okay, to eradicate that, what Hadoop 2.x has taken, they have added one more person, that is nothing but standby name node. Okay, let's try to understand that scenario. Now let's say due to some reason, okay, this person is not able to respond. Okay, and because Zookeeper continuously monitor, there is no heartbeat or there is no time interval with which your name node will respond to your Zookeeper. It does not do that. Okay, like how your data nodes are responding after every 3 seconds to your name node. So that's why Zookeeper continuously keeps an eye or monitor your name node, okay, with a Java program. Now let's say it came to know that this is not responding. So what it will do, immediately it will switch the flags. How it will immediately it will switch the flags? This will be not so. Let me just. So what will happen? This will be quickly made as an active. Okay, quickly it will be made as an active, and this will go in a standby mode. Okay, this will be going in a standby mode. Okay, now what it would be doing is it would be assigning the in underscore use log file to this name node, this standby name node. Okay, and this will become your active name node. So let me erase this and let me write, this will become your active name node. Okay, now as your data node were connected to both the nodes, okay, and now they are able to see, okay, so they are not able to send a heartbeat to this person, okay, but they are able to see there is a in log file. Immediately what they'll do is they'll start sending a heartbeat to this person. So whatever the processes which were taking place, they will keep on continuing, because whatever the metadata pointers this FS image had on this name node, even this had, but it was just waiting for its turn to serve the data nodes. Okay, and whenever it gets an opportunity, it starts serving with this FS image. Why? Because at any given moment of time, this FS image and this FS image are in sync. Because what happens is when the edit logs are written, these are read. Now as this has become an active, the process will change. So this now will be doing a process, and that process will be a write process. Now this will be writing the data to edit logs, and whenever this comes up, it will be starting to read. Okay, now there comes one scenario. Okay, now I have a in underscore use dot log file over here and in underscore use dot log file over here. At both places I have in underscore use dot log file, and this is again like in interviews they'll ask you what is a split brain scenario. Okay, so split brain scenario is nothing but at any given moment of time in my cluster I have two in underscore use log files. Okay, which is like very rare, but again there might be a scenario. Okay, so to avoid this, what Zookeeper does is Zookeeper applies a writer fencing concept, and again it's a Java program. Okay, so now Zookeeper knows this is your active name node because it has a in underscore use dot log file. So what Zookeeper will be doing is Zookeeper will be applying a fencing, which means that it will be applying a fencing to this part, and so there will be a process, there will be, and that process is called fencing. We all know what does fence means. Means fence means like, okay, so let's say I have a plot of let's say some 2,000 square feet. So whatever like at surroundings I create some like bars at four corners, and they are interconnected with some wires, all those things. So we are trying to apply a fencing so that no one crosses from here and there. Okay, so that is a concept which Zookeeper applies. Again, it's a Java program. So what it does is it applies a fencing process so that whenever this name node is up, the data nodes should not send the heartbeat to this name node again, because it has a in underscore use log file. Why? Because it will be your data redundancy or your blocks redundancy or your work redundancy. For that purpose, a fencing process is applied, and this process is applied by a person, and that person is nothing but your Zookeeper. Okay, so Zookeeper applies a fencing to whichever process it has failed, and other person will start serving to the data nodes. And at the meantime, or maybe after few minutes or after 10 minutes or after 1 hour, if this comes back, so this will be made as your standby name node, and the other will be keep on continuing serving to the data nodes as the process is moving. So this will become your standby name node. Let's say after 1 hour, or let's say after 15 minutes, this is coming back. So with the help of fencing, what Zookeeper internally it is doing is it is telling that don't do anything because other person is working. So you just it removes that in underscore use log file. It becomes a standby. Now it starts reading the edit logs and it updates its FS image whatever the edit logs are written. Okay, and one important point we need to remember from yesterday's and today is after every 1 hour your edit logs were flushed off, but here your edit logs are not flushed off. Okay, so whatever like edit logs and FS image, so it is being available over here. So it can absorb, and again like whenever it comes back, again these two nodes, which is nothing but active and standby, they will be in sync. Okay, that's how your yesterday's two scenarios, one is nothing but your failover mechanism, that is if due to some reason your active name node goes down, it does not have to go into the safe mode, and the people like Hadoop admin will come into picture, take the FS image from the backup, and they will try to bring its name node back. Here instantaneously that process is taking place. And second thing is scalability. If I have like one name node, I can have a standby name node, and this name node can also be increased as per our requirement. Okay, as of now I'm just showing this small cluster, but if there is a need that I need to have multiple name nodes and multiple standby name nodes to serve to multiple applications, that can be done. So scale out or horizontal scalability is achieved in Hadoop 2.x architecture. Okay, and failover control mechanism is also achieved. And the third thing is, which I need to explain maybe once we move forward. So job tracker was not able to handle resources outside Hadoop, and that is taken care by Yarn, which is nothing but yet another resource negotiator. So whatever problems or limitations or drawbacks of 1.x architecture was, they were overtaken or taken care or eradicated in your Hadoop 2.x architecture. Are we able to understand this, the 1.x and 2.x?
Yes, sir.
Any
Sir,
questions? Yeah, sure.
Saurabh here.
Yes, sir.
So, will the ratio of this standby and active node would be 1:1 always?
It depends. See, it can happen like, let's say there are in my let's take there is a project, okay, or to be precise, let's say there is an account, okay. Let's say that account is of Barclays, okay. So in Barclays, let's say there are 5 projects are running, okay. So it can happen like three projects are served by one name node, and two other projects are served by other name node, and individually they will be having their own standby name node. So that is all like internal mechanism, and that is always taken care by
Okay.
admin people, and we are not at all bothered about it. But yes, it can happen.
Self Arif here again. So yesterday on 1.x, you said like 4,000 nodes can be added to
Okay,
one name
yes.
node, right? So here, how many nodes can be added at the maximum?
As of now, there is no restrictions, like it can scale up to any number at any point of time. So what I recall of like Paytm and like the Walmarts, they are using like it's like a very enormous cluster which we are using, like of 9,000 and 1,300. So it's like a enormous cluster, 9,000 and 13,000. Sorry, they are using. So it's a very big clusters like investment bankings and these big giants are using. But like what the limitations which has, so there is no limitations. You can scale out as per your requirement. Horizontal scaling is possible to n number.
Saif, this is Venu. I have two questions. The first one is, can the secondary name node ever become inactive?
No, that is just means like we had this in like this component in like your 1.x architecture, and this taken care, and it is just carried forward, and this is just for a backup. So this is like at a very rare scenario when like your entire Hadoop cluster is down. Let's say
Okay.
whatever name nodes which you had, they went down, which is a very rare scenario. Like this node will also go down and this node, but that can happen at that moment of time. Like we will have some backup data at some moment of time, but
Okay.
it won't happen.
Yeah. And in a scenarios like the active name node got crashed, right?
Okay.
So now the standby becomes active,
Okay.
and I think they eject that crashed one out, and they will replace with a new node, right?
Yeah. If you're talking about like this this node will be completely removed and it would be replaced with a new node. You are talking about that?
Yeah, I'm asking.
Got it. So that is a good question. Okay, and I don't have an answer to that. So what I would be doing is, okay, so that's a good question. So what happens is, see, these kind of questions once it comes. So what I do is, in my every batch, I create one notepad. Okay, and that notepad is called as a parking list. I will be saving this. Okay, so there will be few questions which I may not be able to answer because it can happen because I don't know everything. Okay, so when it comes to coding also, or so when it comes to few topics which are which are considered to be coming at a later stage, so I will be keeping those questions in parking list, and I will always keep an eye whenever the question topic comes. Okay, I will try to remember this, and I know because that has been my trend. So I will, as of now, this question, it's a good question because even I didn't thought about. So I'll have to go to some admin person and I'll have to get an answer. So I will keep your question in parking list. So
Yeah. So
does your
yeah,
name node
my
eject?
actual question is, in that scenario, do they restart the whole cluster
Yeah.
to?
So for now, I will
Okay.
be able to just keep it parking because
Okay.
even I don't have an
Okay.
answer because I have never worked in Hadoop
Yeah,
admin.
that's okay.
Okay. So
Yeah.
whether like a restart, okay. So maybe I'll try to keep this and I'll try to go to the admin people because there are a few people like friends in my group, so they're admin. So I will try to remove this answer and get back in the next session most probably. Apart from that, we can whatever the questions are, you can ask. Ideally, that is my
Yeah, I'm
assumption
good.
again.
Let's start
I'm
with
not
it.
sure. That is my assumption. I don't know. They might be removing, they might not be removing. But let's not go on assumptions. Let's come with concrete answer. Okay. So I've just kept in parking. So any questions? Yes. No. Are we able to understand small concepts? Yeah.
Ubaid here.
Yes, Obed.
Uh, just want to know that split brain scenario. How
Okay.
much time it will take? Means as
It
you
will.
told me that,
Yeah. Yeah.
as you told that. Let's suppose this has been name node has been dead, and it's not responding. So let's suppose they are giving the heartbeat to them every 3 seconds or so. So how much time it will take to means respond it to the split scenario, brain scenario, so that it will be inactive and that will be active.
That will happen in very microsecond. We will not be able to know that because it will happen in such a micro fractional second. As soon as this is not responding immediately, this lock will be sent over here and this heartbeat will be sent to this, and what a zookeeper will do immediately, it will apply a fencing to this so that no redundancy will happen. That will be a very minor fraction second of it will happen.
And how when it is restarted or reactive, this standby node
Okay.
come
Okay.
again. So how it come to know to zookeeper means they to put any program or any
Yes,
functions
yes.
there.
So with this, so if you see, they have applied a fencing writer, which means that it will not. So whatever data nodes they are responding now. Earlier, if you see, they were connected to both the one, but they were responding to this first one because it was an active name node. Now,
Hmm.
Zookeeper has applied a fencing writer, which is a Java program. What it will do internally, it will just means apply some like some bar or some range so that nothing will trouble until unless it comes up. Now, let's take an example. Your question. This becomes up and running. Okay, so
Hmm.
this will be in a standby process, but the lock which it had during the fencing writing process, Zookeeper removed it. So now they are just connected to it. They are not sending the heartbeat. So they are just connected. And now this standby name node is waiting for its turn. If due to some reason this gets failed, this will become active.
So fencing will be monitoring that stuff.
Yes, fencing writer. That's a Java program again.
Okay.
Yeah.
And that even the failover controller will not be working if we put a fencing
Yes.
over it.
Again, this failover will be a standby name node. Again, this is a Java name node because Zookeeper has to make, let's say if this fails, so it needs to be active, right? So there is
Hmm.
a program written in this failover controller. Immediately, it will make this as active.
Okay.
Okay.
Fine.
Yeah. Any questions? Yes. No. Maybe. Okay. If no questions, then yeah.
Sorry. Sir, Chiranjeevi here.
Yes,
So
Chiranjeevi.
I have one question. So in that, I want to know that the journal node containing the edit logs, right?
Okay.
So in that, what is the size of that, or how many times? How many hours it will be contain the logs? All these things. It will be defined in the configuration file, right?
Yes, again, all these are like configurable concepts. Here also. So based on our project requirements, we can configure each and everything. And I will be showing maybe like once we go open our Ubuntu virtual machine. So there are some files like core site XML, HDFS site XML. So these are the files which are MapReddite XML, Hive site XML. Every ecosystem has its own XML file. There we can override the default properties. Yes, all are configurable.
Okay. Thank you.
I'll just pause. Okay, so you just need to click on start. This will take a time of for the first time it might take a time of maybe like 2 or 3 minutes, and from there onwards like it should take a time of maybe like 1 or 2 minutes. Okay, now there will be certain credentials which you will have to use, and as we practice, as we move ahead slowly and steadily, I will be telling you all the credentials. Okay, so meanwhile if it is opening, let's create a new notepad. Okay, and in this notepad we will be keeping all the credentials. Okay, cool. Now, so to connect your Ubuntu VM, okay, so there is a username given, that is nothing but Ceph. Let it come. Let's drag it down. Okay, if you see the username is given Ceph, just close this, and if this is open, you can close this also, that is not required. Okay, done. So let's come back. There is a password assigned to this machine. Okay, the password is welcome@123. Okay, I always try to keep password in a general manner so that whenever like you forgot and you come back to me, I will be able to say. Okay, if I keep, and again like if you change the password, then again it will be a little concern, but there are ways to remove passwords or create more users, but let's not fall into those things. So you need to click on this, just need to enter the password welcome@123. Okay, so your machine will be up. Now people have asked me these questions, so the configuration what they need is I would expect like, this machine is expecting minimum of 4 GB RAM, but if you have a 8 GB RAM as minimum, it would be a very good thing, because 4 GB will give you a lagging process. Okay, cool. So what we did, we entered username and password. Okay, no questions till here. Okay, now if you have any questions, you can pitch in any moment of time. Okay, now I want to start because see, once you go into industries or project, there all your services are up and running at the background, but here knowingly I have not kept those services up and running, because we should understand with which service what is starting and how we are starting. So with that we'll come to know, okay, this is needed for that, that is not needed for that. So that's why I have kept this, by knowingly, intentionally I have kept this. Okay, cool. Before that, let's take one more small example. Okay, so we got to know how to connect to this machine, that's it, with a username and password, nothing else. Now once you go into the projects, okay, you will be you will be either logging in with the, let's say I have got into a project of HDFC Bank. Okay, so let's say I'm working with one organization, let's say example Infosys. So I will be having a credential of Infosys to log on the machine, and I'm working on an HDFC Bank project. So I will be having credentials to log in into that account, right? I'm making sense to everyone. Yes, no?
Yes.
Cool. Okay. Now let's say you have logged in to the credentials which were given by your project, and you are entered into either Citrix, via Citrix, or let's say RDP or VDI, whatever the things is. Okay. So there is someone, and that someone is nothing but Putty, right? You know Putty. What is Putty? Let me know if anyone is not aware of Linux. I guess like Irfan, and I think like you said, like you are not familiar with your Linux and shell scripting, right? Mostly shell scripting is like again an advanced part, but again like when it comes to Linux, so today onwards I will be sharing something. If people are not good with shell scripting, so they need to, every week only one video. I don't want lot of studies, only one video. Okay, and slowly we'll start writing shell script also, because next week onwards I will show you, because this week I will be sharing you one video and you need to go through that video and come up on next Saturday or Sunday. That is scoop. Only one video. So because from next week Python assignments will start, scoop assignments will start. This week nothing will start. Okay? So let's come back. Putty. Now in Putty what you do is you enter your host name, right? Whatever the host name is given by your account. Okay, so you try to enter your host name, and you try to give this machine name. Let's say this is a dev machine, right? So let's do that. Okay, so before doing that, see if this message is coming up, do not do anything, just say remind me later. Do not do unnecessary things, because we should have this machine till the end of the course and again after the end of the course. Okay, either you can click on this terminal, or what you can do is right click on the terminal. Okay, or we are all working professionals, so I hope like these are all basic things. So here I'm just trying to write a small command, ifconfig. So with this ifconfig, I'm getting a IP address. So what I'm trying to do, I'm trying to go to putty, I'm trying to pick over here, paste this over here, and let's say this is I already have that. Okay, so let's say batch training. Okay, so whatever, if you want to save that, okay, double click and open. Okay, so just say yes. Let me minimize this, this is not needed. Let me increase the font for you so that it would be clearly visible whatever I am writing or whatever we are practicing. Okay, now what is the username which I told little earlier? So username is Seth. Okay, what is the password which I told a little earlier? The password is welcome@123. Okay, if you see, I am able to allow to access. You can practice from here. So let me clear off the screen. If you present print working directory from here, or if you present print working directory from here, we are at the same path. Okay, if you want to practice in this virtual machine, you can practice. If you want to connect with your putty, you can connect. It's your call. Okay, cool. Let's come back to the explanation. So what we did is we gave some host name. Okay, so we gave some host name. Okay, and we gave some name something, so just to identify. Okay, and we got connected. When we got connected, okay, when we got connected, so the place we are, that place is called edge node. What this place is called? This place is called edge node. Either you can say it's a client or an edge node. Remember yesterday I was telling, or today also in the 2.x architecture, client, edge node, client, edge node. So this is the place. So this is the place that is your edge node. Okay, on edge node, you can execute all your Linux based commands, okay, based on your OS. Okay, so what you can execute? You can execute all your Linux based commands. Okay, so let's go a little over here, and let's say I'm just trying to do change directory to LFS dataset. If I just try to do ls, so there are some datasets available. Okay, so here I am trying to write some command calendar. If I just write date, present working directory, who am I, whatever, all the commands are working which we know of Linux. So in a similar fashion, at edge node, you should be able to execute your Linux based commands. Okay, now at the same place on your edge node, when you try to type your HDFS commands, okay, so those commands are not getting, they are getting executed or they are getting triggered on your edge node, but they are getting executed or performed in your Hadoop cluster. Where are they getting performed? In your Hadoop cluster. And we all know now how the Hadoop 1.x architecture looks like. So I'm just draw a few blocks. So let's say this is like a name node, and let's say these are two data nodes for us, and let's say there will be one backup node. Okay, just I'll not go in much depth. So just for understanding, so let's say this is name node, let's say this is data node, and this is also data node. Okay, and what this is nothing but your Hadoop cluster. Okay. So if I try to execute a small command, don't worry about this command because we will be starting with all commands slowly. Okay. So I'm trying to write hdfs dfs -ls. Okay. And I'm just trying to write / means all the listing from my root. So when I'm trying to execute this command, okay, so this is getting executed at a certain place. Okay. And now if you see, when I am trying to execute the command from here, the commands are getting executed in this cluster, but it is giving me an error and it is telling that from this IP, okay, this is the host or whatever user is not able to connect to localhost 9000, which is the port for Hadoop. Okay, don't worry, I will show everything slowly. It is giving some error and it is telling us connection refused. We will not get these type of errors in projects. But this is a virtual machine prepared by me, and again I could have not shown this error, I could have directly shown you the working environment, but whenever we get issues or errors and we know the solutions, so we always remember. So I try my best to show you the issues and then show you the solutions. For that purpose, either you can go over here or you can go over here. So you have to type two commands. Okay, so first command is start-dfs.sh. Okay, before that, let me show you one command, JPS, which is nothing but Java Programming Service. Okay, now if I say start-dfs.sh, this will start your name node, this will start your data node, and this will start your secondary name node. Okay, so it is starting. So whenever you connect to this Ubuntu machine and if you want to practice, you have to trigger these commands. Okay, so start-dfs.sh, and the second command is nothing but for resource manager and node manager, that is yarn.sh. Okay, now if I try to execute JPS, I can see that. Now let's try to write start-yarn.sh, and it is starting my resource manager and node manager. Okay, and let's stop and let's clear off the screen and say JPS. Okay, all the required daemons are up and running. Now if I try to execute my command hdfs dfs -ls, okay, it is throwing me or it is giving me certain things. Okay, and these are nothing but which is part of your Hadoop cluster. So it is nothing but here. So are we clear on these things? So what is edge node and what the commands which I am executing with HDFS, they are getting executed at a certain place.
Seth,
Yes.
Vijay here.
Yeah, Vijay.
Sorry to interrupt.
No issues, no issues.
Yeah, so I just want to know that Kerberos is set or not here?
No, Kerberos is not set because that is always, yeah. So what is a Kerberos authentication? Okay. Now in projects, you will get a Kerberos authentication. Okay. So what happens in Kerberos authentication is means whenever you are trying to connect with your username and password, okay, so there is like one key tab file is given to you. Okay. So key tab file is given to you, so which is nothing but as said by Vijay, so that will take your Kerberos authentication, because no user can directly access to your Hadoop cluster. For that authentication purpose, the Kerberos authentication is implied. Okay, for that we need a key tab file, and in my batch we use a batch user and this key tab file and the whatever like small arguments are there, so we use that, and with the help of that we are able to connect to our Hadoop cluster from the client or edge node. Got it? So what is Kerberos authentication? It's just like an authentication or validation. So a valid person is connecting to my cluster. That is not installed over here that is not taken care over here to answer your question, Vijay.
Got it, thanks.
Yeah. ठीक है? So we are able to understand this. We are able to understand. Any questions still here?
Hi, Safe. Satyajit here. Actually,
Satyajit.
in between I lost because of some network issue in my area. So it's all are recording now.
Yeah, don't worry. Everything is recorded once we finish, because yesterday I took time to provide you everything, because I was getting emails slowly. So that's why it took
Yeah.
me like, I just waited for 2-3 hours and then I sent finally. So from today onwards, it will be just within 15 minutes you will get that, because I have the emails ready with me.
Okay, fine. Actually, you had heavy rain actually
No
because of that
problems, no
some network
problems,
issue.
no
Yeah.
problems. Certain
Thank you.
circumstances will occur. Don't worry. We are there.
Thank you.
And even if you face any issues, WhatsApp group is also there. You can ask questions.
Okay, fine.
Don't
Thank you.
wait till Saturdays and Sundays.
Yeah.
Okay. Okay. So we are able to connect everything. Cool. Now, let's make a step move ahead, because this week I will be giving you a scoop video to practice. It's a 2 hours video, not much. So from your professional time and your personal life, just try to remove 2 hours and go through this, because first month we will be building a base. For people who have scoop and hive knowledge, it's good, but for people who are new, so it's just a 2 hour video. Every week only one video will be given. So it's properly designed, nothing will be overburdened to you. The only thing is we need to go sequentially. Okay. Now, what is a scoop, what is not, so everything is explained in that video. So here I'm just trying to show only 3 components as of now, because we would be practicing, because only, I think for today I will show only scoop, because once we start hive I will show you how to connect to hive and how to write all these commands. Okay. Now, when it comes to scoop, so I'll just give a small description. Scoop is nothing but a combination of, okay, so Hadoop and SQL. It's a combination of that, so that's how they call as scoop. So just to give us basic idea, it imports and exports the data. Okay, it imports the data from your RDBMS and writes the data to HDFS file system, and similarly it exports the data from HDFS file system and writes the data to RDBMS. You can go through the scope. I have explained with my best knowledge, and all practical implementations are also there, so you will get it easily. Now, how will you execute your scoop commands over here? Okay, before that, before going to scoop commands, okay, see, I am in my working directory called home/sef. If I do ls-ltr, okay, mostly like you might not be seeing everything, because these are my like previous batches, everything it comes for you. Hopefully like few, like it will be like templates, videos, music, documents will be there, because, and this LFS hopefully it won't be there, and AWS, all those things won't be there. So it will be having few directories which are already, so you will be getting a brand new machine. Okay, so what I have done is, if I just change directory to LFS, which is nothing but local file system, I will tell you, and if I just try to do ls-ltr, again like you might find or you might not find. So if you see, there are some directories which I have created: jars, data sets, scripts, environment. Okay, so we will be getting this slowly and steadily as we keep progressing. Okay, so we will get all this. So if I do, so let's say VIB5, so okay, so we would be writing scripts slowly and steadily. Okay, so if we just go to data sets, hopefully I think like data set should be available. If it's not available, I will be sharing the data sets on G Drive access. You will be getting all the data set, don't worry. Hopefully the data set should be available. Even if it's not available, whenever there is a requirement, and if you find that missing, just post in the WhatsApp group, I don't have this file, I will immediately share with everyone. Okay, so let's come to a place. Let's say if I'm trying to do ls-ltr, so you will not be having this LFS folder. Okay, so we all know, if people are new, so now let me commands. Okay, so I can write that command. Okay, let's come that to here. Even this is brand new, so let's write that command over here. So what you will do is, simply you will type before this, simply you will type a simple command mkdir and lfs. Okay, so what we are trying to do is, See how I have created this just to segregate. I could have written everything in one go in the same place only, but just to make like segregate at a place like, okay, this belongs to this belongs to that. So that's why what I have done is everything has been segregated to certain places. Okay, so what you need to do is you need to create a directory where you will be storing all the data in your local file system, okay, which is nothing but your edge node. Okay, so if you see, that's why if I just do change directory, capital L, and if I press tab, so here you will not be finding all these directory. Okay, slowly we will start creating this, don't worry. So if data sets is not there, what you can do is simply you can write mkdir and create data sets. If you don't want to use this name, if you want to use your own name, you are also welcome, no restrictions. But try to give some meaningful name. Okay, when I'm trying to download some jars, I will be keeping those things under jars folder. When I'm trying to do some scenarios, I will be keeping under things. So when I'm trying to define some param file or environment file, so that will be under something. If I'm trying to write some scripts, that will be under something. So we'll try to make some sense to this environment. That's why I'm trying to do or trying to follow a process. Okay. So for us, as of now, if LFS is not created, so you can execute this command and you will get, and if this is also not available, so again what you can do is you can first you will have to change the directory to LFS so that you will be under that directory, and in that you will have to execute this command. So you will be having, as of now, that is only required for us. Okay, so that is one thing you will have to do. So this will be like you will be having all the data in your local, or you can say on your edge node also. Let's say edge node. Okay, now similarly, as I told you, so we have edge node and we have Hadoop cluster. So if you want to put files, if you want to remove files from HDFS, so again, like, you will not be able to execute this Linux based commands. Okay, so for Hadoop, okay, and again, like, you can write your command like Hadoop FS or HDFS DFS. I will tell you the meaning once we start. Okay, but for just now, what we will do is we would means like once I give you the systems, you'll have to do what you will have to do is you will have to create directories so that you can push your files to the Hadoop. So where you will do that? Okay, so let me go back. Let me come out of. Okay, even if you are there, no issues. Okay, so HDFS DFS. So whenever you are trying to write this command, it means the commands are getting executed on your cluster. Okay, so HDFS DFS -ls. So if you see, so let's go step by step. If you see, when we were executing this command, we got this. So we need to go into this user, the last one. So this will be by default, huh? So safe, even safe will be by default. Okay, till here it will be by default. Okay, so till here it will be by default to available to you. Okay, so this will be available as. So what now you have to do is you have to create a directory in HDFS. Okay, which I have already created. Okay, so that is nothing but with the name of HFS. Can you see this directory? I have already created this. So what will be the command to do that? HDFS DFS. So you write mk directory, right? Mk directory is the command. So the only thing is you need to add a prefix hyphen and the same command will work. Okay, so the path, that is nothing but user, safe, and what is the directory name. That's it. For me, it's already created. For you, you will have to create. Okay, I'm hitting enter. So I am interested only in these two, input and output. Okay, so again what you will do, you will again copy this command, input, output. So output directory you will create and input directory you will create. Why you will create this is because whenever you want to push your files from your edge node to Hadoop, that will go to your input folder. just to segregate things, okay? And whenever you are trying to write the output either from PySpark or structured streaming or AWS or Hive or wherever, Scoop, so the directory, if you're writing in Hadoop, so the directory will be output. Okay, just for segregation, we need to understand, because once you go into projects, there will be so many paths. So you need to understand, so what is my edge node, what is my Hadoop. So in my Hadoop, what are the directories and what are the segregations. Okay, so this is how you will have to prepare your environment. Okay, so these are Hadoop services or Hadoop shell commands to start Hadoop daemons. Okay, any questions here?
Hi, Saif. This is Satyajit.
Yes, Satyajit.
You have mentioned Hadoop HDFS, DFS something. This is like with this command, we'll get the Hadoop like HDFS related all the things.
Yes, perfectly right. So whenever we are trying to write HDFS, DFS, okay, so Hadoop commands can be executed in two forms. Either you can write Hadoop FS and your command, okay, or you can write HDFS, DFS or your command, okay, whichever you are comfortable with. I am comfortable with this, so that's why I use this. Now, whenever you are prefixing either Hadoop FS or HDFS, DFS, it means that we are communicating with your Hadoop cluster, which means that this will be fetching the data, or whatever we are writing in the commands, it will be working in your Hadoop cluster. Apart from that, whatever Linux commands which we are executing, that will be giving the data on my edge node. So these two things we need to understand very clearly.
Okay. Yeah, got it.
Okay. So
Yeah,
how to connect to the Ubuntu machine, I have told. How to connect to a putty, I have told. Okay. How to start your daemons, which directory you need to create in edge node as well as Hadoop. Okay. Any questions?
Yeah, in production environment, does file come on local system or it comes directly on Hadoop file system?
It's based on your FTP or your CD. In my project, we have a connect direct setup, CD setup. Okay, so there, like, we are landing the files directly into HDFS. Okay, so it's based on your project architecture where you are landing. So mostly it will be your HDFS where the files are landing. Hello.
Yeah, we can hear you.
Okay. So I don't. It's like, did you get the answer?
Yeah.
Yeah. Okay. Now, this week I will be giving you a scoop video, so you need to go through it. So I will be just writing a small scoop command. Okay. It's a very simple command. I will be just showing you how to write the command, which is already explained right from the scratch, but I just want to show you. Okay. Now, before that, there is MySQL instance also installed in this. Okay. So how you will connect to your MySQL instance? So you will write MySQL -u, okay, that is the username. So the username is root, -p, the password is welcome@123. So this is the command. Control C. I don't want to play with this, so I will open a new terminal. Username, password, clear of the screen, execute the command. You are in the MySQL instance. So all the Linux based commands you will be able to see. I have created a SafeDB for the practice. You can create your own databases, whatever name you want. Okay, but for scope practice, we will be needing this database, and I will be providing you the SQL file. And how to load the data from that file is being instructed. Okay, so what I'm trying to do is I'm just trying to use that retail_db show tables. there are some tables, okay, and we are all good with, okay. So this is how you will connect to your MySQL instance. Now Scoop, Scoop, what it does is, as I told you, it imports and exports the data. So Scoop has been deprecated, just for your knowledge, but Scoop questions will be asked in interviews. For that purpose, we need to know this daemon, okay, or this ecosystem. So there is a command which you will have to write, okay. So what that is command is, so again it has few parameters, and again it has few arguments, okay. So if you start with the Scoop videos which I would be giving, slowly you will be getting everything nicely, no tensions, nothing, okay. But how to write the command, how to do this, everything is being done, but I'm just showing a quick flow, and then we'll start with the HDFS command because time is running for us. So what we need to do is, simply we just need to write Scoop, okay, and the argument is, let's say, hyphen list databases, okay. So what I'm trying to do, again, this is one of the command, okay, everything is explained, so don't worry about this, why I'm writing this, why I'm doing this, because everything has some sense which is explained in the video nicely, okay. Now you need to connect, because you need to connect to some databases, right? So with JDBC connection, to which database you are trying to connect? I'm trying to connect to MySQL database, okay. What is the host? For now it is a local host. Maybe like once you go into project, there might be some host name given to you, okay. What is the port name? The default port name for MySQL is 3306. If you see, for Oracle it is 1521, for Redshift is 5439, for SSH, which is nothing but secure shell, putty 22, okay. If you go for web, HTTP 8080. So all our different ports are assigned. So by default 3306 is the port which is for Microsoft SQL, okay. So list databases, so I want to connect and list. So what is the username? Okay, so the username is root. What is the password? The password is, again, I have tried my best to keep the consistency in password so that when we are in the learning phase, we should not get issues, okay. So where you will execute this command, so see on the edge node, I'm just trying to write this command and I'm trying to hit this, okay. So it is telling me list databases, okay. So there is issue with some command. So Scoop list hyphen databases hyphen connect JDBC colon, okay. So the command is, let me cross check, okay. So Scoop hyphen list, okay, that is correct. List hyphen databases hyphen connect with the JDBC MySQL / localhost port 3306, even that is correct. Username is root, password is welcome @123. So what is the issue it is telling us? Let's no
Is it
such
asking for MySQL password?
username is root. Yeah, the password is same.
No, you mentioned MySQL password would be p welcome at 123.
No, that P stands for password.
On
U
okay,
stands for
okay,
username, P stands for
okay,
password,
okay.
okay. So let me just quickly, what is the issue? So Scoop list databases, or otherwise we will change the command if this, but again, like, it is not giving something. So username is root, which I am able to recall, and JDBC colon MySQL colon, so even that port is correct, okay. So the error we are getting is no Scoop tool list
The
databases,
scope
okay.
S will be in lowercase, I think.
No, the command which I am writing is, so that is,
Actually, Saif,
that's
hyphen list is there, right? So you can, I mean, we can ignore that hyphen.
okay. So
List.
yeah, because Scoop actually not working on this, yeah, right. So that is an argument issue, okay. So this is coming, okay. So we are getting an issue. I will eradicate this issue also, but before that, let me show you. Can you see the databases, show databases we were getting earlier? We are able to get the same database. If you see, earlier when we were writing the command show databases, okay, we were getting this information schema, MySQL, all these things when we were trying to do. So when I'm trying to do a command, so everything is given, don't worry, so you'll get it. Okay, now how will you eradicate this SSL exception? So what you need to do is, let's go over here, okay, and I think use SSL equals to false. Okay, so let's quickly copy this. Sorry, let's clear off the screen and let's hit enter. Okay, so we are getting, so I think like it should be, okay, if you see that error is gone. Okay, so these are some small issues which has already been encountered, okay, and that is been there and told. Okay, but for my what my perspective was, I just wanted to show you how to connect, that's it, and how to run. So all these are being taken care in the, you don't need to worry. Okay, so hopefully
Hi,
like if, yeah,
hi Siddhi Satyajit again. Yeah, actually some silly question I have asked again.
okay.
Users SSL equal to false, what does it mean?
So what does
You have
use
added.
SSL fall means is, see, when this connection is getting trying to get established now, so that connection established, it is facing some issue. So that connectivity issue is not able to establish, because of that there is some issue we are getting. So just to remove those issues, I'm trying to use SSL false, because it's expecting some secure layers connection. So for that purpose, I'm just writing, please remove that authentication, and I'm just telling it false.
Oh, okay.
Okay.
Okay. Yeah.
So what I have shown in this small, like how do you will connect, username, password is welcome at the rate 123. You can execute all your commands here also. Whatever I'm trying to execute here, if you want to execute into your virtual machine also, you are free to do. No restrictions. Okay, wherever it will do, because that machine and this machine is the same. If you want to practice here or with putty, it's your call. Okay, so necessary things, whatever is required for you to practice till this 1 month, so this is like you will be there. So you will be going with, again, like once we start with Python, I will show you how to start Python, how to start notebook, PyCharm, that will be taken care. Any questions till here? Okay, if no questions, then can we take a break of, let's say, quick. Now we will start with all the HDFS commands. Okay, so this is like, if you know like Linux commands, HDFS commands becomes very easy for you. Okay, it's not a big thing, but again, like we will try to see some 18 to some 20 commands, so that at least in a day to day, means like I use not more than like 5 or max to max 10, but still we need to have a lot of thing with hand. Okay, now file, what I will be expecting from you is, okay, so this is the file which we are creating, right? So this is, okay, so here again I will only create this and I will only share for you. Okay, so what is LFS path? So the LFS path would be /home /saf and /lfs, right? If you are creating a folder with other names, so your folder, so whenever we say edge node or whenever we see LFS data, so this will be under this path. Okay, so these are just small things which you'll have to take care of. Okay, so let's say whenever we talk of Hadoop data path, okay, so let's say Hadoop path I'm writing, so that is under something called, so user save HFS directory you will have to create, and under that there is a input directory created, right? So similarly, so let's say Hadoop input path, I would say. Okay, so and this is nothing but Hadoop output path. Okay, so this I need to change. Okay, so this is already been done because I have already instructed, so we are done with this. Okay, now there are certain web UIs which you can see. Okay, so if you want to see resource manager and if you want to see name node, so there are some web UI ports. Okay, so let's say web UI for name node. Okay, that is at a location, and that location is nothing but HTTP. Okay, then you have your IP address, okay, then you have a port, and that port is I think 9870. Okay, so let me cross check what is my IP. I think it's 192.168.0.105, right? IF config, that's what we have seen earlier. Okay, so let me copy this IP address and let me replace this over here. Okay, let me copy this piece of, and let me go over here, let me open a new browser and let me hit enter. Okay, so whatever the file system which I would be playing through my CLI, okay, because in projects you will be always seeing this black screen. Okay, you can do that with graphically also. So here you will get an overview of your Hadoop cluster. So once you go into the project, everything is given. If you remember, at the start we were getting an error that it was telling us connection refused to localhost 9000. So we started few services. Okay, so that's how the relations are coming. If you remember, like something like, as I told you, safe mode is off. Okay, which means like we are in something. So you just go through it, whatever, like if you can understand what are the live nodes, data nodes, dead nodes, you will come to know. But as a developer, we don't worry about all these things. Okay, that is like your admin people who will be monitoring all your cluster health and etc. For us, this becomes a little important. Browsing of file system. If you remember, like I was trying to write the commands, so here you can navigate it graphically. User, safe, HFS folder, and we had input and output. So input files, all the files. Okay. Similarly, we had output files. Okay. So this is your web UI for your name node. Similarly, we have a web UI for resource manager. And I have not explained yarn to you, so that is pending. So web UI for resource manager. Okay, so let me copy this as is, because port number would be same. Port number would not be same. So the IP address would be the same, and the port number will change to 8088. Okay, so let me copy this. Let me go back and let me paste this. So here you get your cluster information, okay, whatever your job you are executing. So in interviews they will ask you questions. If you map reduce job we just started of customers, okay, so you will get all the logs, whatever has happened inside this, go through that, whatever logs we were able to see. Okay, so you will be able to get that here also. Okay, everything is there. So you just need to understand, and we just need to go and navigate. That's what we need to understand. So finished, so some processed or whatever, slowly and steadily you will start getting to it. Don't worry. Okay, the only thing is you should know the navigations first of all. So that's what the navigation I'm trying to show. So you can just navigate through this and you will be able to get it. Okay, so this, but I have not explained you yarn. So once we see yarn you will be able to see. Okay, for now I'm just sharing you. So explore if you want to explore. Okay, whenever you have doubts, questions, you can ask. Okay, let's come back. So these are the few things which I have added. Okay, moving ahead, we will keep on adding. Once we start with Hive, we will add Hive path. Okay, and we can act. So actually I'm working with an admin person, but in this, like, Beeline is not installed. So, and I was struggling to install Beeline. So if I get a help from an admin person, if that issue is eradicated, so I'll tell you how to log into Beeline and how to connect through a Hive interface also. Okay, so slowly, then NiFi, then whatever Kafka, whatever. Moving ahead, we'll see slowly and steadily. Now let's come back where we need to write, or where we need to start with my HDFS command. So all these two things are done. Okay, so I've shown you how this Ubuntu machine will be having. So in this Ubuntu virtual machine, we have installed all the ecosystems which we need for practice during these 4 months, and every ecosystems are with latest version. Okay, so we don't need to worry about those things. So let's start with HDFS commands. Slowly and steadily we'll understand step by step what are the commands which we need to understand. Okay, first of all we will understand a small difference between HDFS, DFS and Hadoop FS. Remember, I told you a while back that we can execute the command with this prefix or with this prefix. Both will give me the output. But what is the difference? Okay, so I will just talk about this and this. Otherwise, HDFS and Hadoop means the same. Okay, so FN stands for normal file system and DFS stands for distributed file system. So FS means refers to any file system. Okay, so it could be local or HDFS or anything. Okay, so it could be local or HDFS. Okay, but when I'm talking about DFS, okay, so DFS refers only to HDFS file system. So this is specifically to your Hadoop file system. But if you want to interact with other file systems, so you can use Hadoop FS commands. That is a small difference, nothing else. Both commands will give you the same result. The only thing is writing way there is a small change. Otherwise there is no change. Okay? So I am habituated to directly accessing the DFS commands using DFS. So I will be practicing with using that. If you want to means again it's your call, whatever you want to get habituated or looks good, easy for you. Okay, so let's start with the first command. Okay, so the first command is nothing but list. Okay, so what it does is, what it will do is it will list all files. That's what we have seen earlier, right? HDFS, DFS -ls and the path. So if you want to see, let's say of root, if you want to see, you can just give this, or maybe user saf, and we had a directory called HFS, which is nothing but Hadoop file system. So let's copy this and let's execute this piece of command and hit this. So now if you see, when I'm trying to execute, whenever I'm trying command ls, which is nothing but a normal Linux command, so the same is been prefixed by hyphen. Okay, now you are not sure of your command, so what you can do is HDFS DFS -help. Okay, so if you remember, like in Linux, what we do is we write a man, correct? But here we write HDFS DFS -help. Whatever commands are there, all the commands are available with their description, with their explanation. So if you remember, we used mkdir, creates a directory. Now there is an argument or a flag which we can use. What does that means? -p. It means that if my directory is available, the command will not fail. So you can explore your help command and you can play with your commands. Okay, so if you want to get any help for HDFS commands, so simply you will write Hadoop commands help, you will write HDFS DFS -help. Okay, cool and straightforward. So we are good with the first command, that is like list. Okay, so which will list all my files. Okay, the second command which we have already seen, and I will not execute that, so that is nothing but mkdir. Okay, so it will create directory. Okay, so I'll quickly write that. So HDFS DFS, let's say -mkdir. Okay, so let's say the path is nothing but /user save, and let's say if you want to create under this, let's say Hadoop folder, if you want to create, you can create under that. If you want to name like in a lower case, I have mentioned in title case, it's your call. If you want to name with other naming convention also, you can name, no issues. Okay, so these were like two basic commands which we already covered, so I'm not covering those commands. Okay, now the third,
Sir,
yeah,
we can execute Hadoop FS command at same terminal.
yes, same here
Okay.
also. So if you just go over here, so let's Okay, same command you can
Okay.
execute.
Okay.
No restrictions. Okay. I missed to prefix the hyphen because okay. So the next command is nothing but put command. Okay, or copy from local. The name itself suggests what it does is it copies files from edge node to Hadoop. Okay, that's what it is saying us. How the syntax? So first of all, what we will do is, if we were just trying to go to the input directly, so what I will do is I will just come out of this because this is not needed for me. So here I will write all my HDFS commands, and here I will write all my Linux command. So you can play with your sessions. Okay, so HDFS DFS -ls, and I was just writing a command called user save HFS, and under that I have a directory called input. Okay, so here all the directories are there, and on my local file system, let's say I am trying to do ls. So for that I just need to move, because I have already created a directory datasets, as I told you earlier. Okay, so I have already told under this datasets there are some datasets kept. Okay, so what we will do is, there is a file called movies.csv. Okay, so we need to move that file over here. So let's understand that movies.csv, is that file available or not available. Okay, it is telling that no such file or directory. How can you move? Okay, so the simple command is, you just need to use either put from copy or from local. Okay, and again, like, what is the difference between this? So again, like, there will be some, this week I will give you some theoretical questions, and that is one of your question. Okay, so the command would be HDFS DFS. Either you can use put or you can use copy from local. Okay, from where you need to copy or where you need to put? So it is from my edge node, and that path is this. What is the file name? Okay, so the file name is nothing but movies.csv. See, you might be wondering like how I remember this path. Okay, once you start practicing, all these paths will come to you slowly and steadily. Okay, don't worry about those things. It comes by practice. Where I want to move this file? I want to move this file under input directory. Just copy this command, and so let's execute it. Let's execute here also, no issues. Wherever I can execute, it will not make any difference. Okay, and if I just press up arrow, all my previous commands I can get. Okay, up arrow, down arrow, you need to play with it. Okay, so here I was just trying to write earlier, I was not able to get my file. Now hopefully I should be able to get the file. Okay, so either you can use put command or you can use copy from local. Now if I am trying to execute the same command, we will get an issue. Okay, so it is telling me file already exists. So what you can do is, so if you want to come back, you can press Alt B. So word by word you can go back. You can press Alt F. So word by word you can go back again. Okay, so small things, but these will make a difference. Okay, so -F forcibly put that file. Okay, now how I know this? Again, you need to go into this command HDFS help. You will be getting all the arguments. Okay, few things which we do in our day-to-day life, so we remember by heartedly, so we don't need to refer. But initially, as we are new learner, so you'll have to go to the help command and you need to find out what is the right flag or the right argument which you want to use. Okay, so here I'll just mention that -F if it is required. Okay, cool. So we are able to put the file. Now if we are able to put the file, I want to see the contents of the file. So the command is same command which we have, cat. So to view the data. Okay, so the command is nothing but HDFS DFS -cat, and from which file I need to view the data. So I'll quickly say this is the file, right? No, user save input at this location, and the file name is nothing but movies.csv. Let's copy this, and I think there are so many records are there, so I would use just head -5. I'm just seeing first 5 records. Okay, let's clear off the screen. Let's execute this. Okay, so we are able to see only first 5 records, okay, whatever we had, including the header. Okay, now here the question will come, not all Linux commands or Unix commands are incorporated with HDFS. Means like HDFS has not taken everything from Linux. They have taken few things, but not all commands will be there. Okay, so there will be few places where you will not be able to write the same commands. At that moment of time, you need to go to your help and you need to understand whether that is available or not. Okay, cool. So we can view the data. Okay, now if we can put the data, if we can view the data, we also now like we can create a empty file with a touch command. So the same Hadoop also gives us the flexibility, or they have also this command. Okay, so what it does is it creates a 0-byte file. Okay, so what I will do is I'll just do quick copy paste because I just want to save a little time. So what I will write, touch command with a Z. So touch they have used. They have not used the same thing. So what we will say is, let's say I am trying to create a file and I will say that file name is, let's say, empty.txt. Whatever name you want to give, you can give. These are all your basic commands to play with HDFS, nothing else. Okay, so that command is executed successfully or it is not it has not. So what we can do is we can just write echo $? If the output is 0, which means that my previous command was successful. Okay, and if I just write not this, and if I just write this command, okay, and it is giving me an error, and if I write echo $1, it is giving me some other number. Okay, so when we are trying to write shell scripts from next week onwards, we need to write error handling also. Okay, what I am trying to say error handling is, so let's say change it to LFS dataset scripts. I think under LFS we have scripts. Okay, so let's say VI B5 scripts. Okay, so if you see, there are some small error handling concepts which we have written. Okay, so you also need to write all these error handling concepts. Slowly you will come to know. Don't worry, it will come by slowly. It's not that eventually, yeah, people who have the knowledge, it will be like they will be able to do. But don't worry, even people who don't have the knowledge, so only one video every week, they will have an extra work apart from school. So they have to go through that video again. But again, like that is not just a 1 hour video. So if you learn that, so next Saturday I will show from basics like how to write a script. Okay, but for that you should have the knowledge. So you need to go slowly through those shell scripting videos. Okay, let's come back to the HDFS commands. Okay, now we completed 4 to 5. So okay, so we were going for the touch command. Okay, so we already executed. So if I want to just view the data or see whether that file has been created or not, so I'll just use my ls command, and the place was nothing but sef lfs, sorry, not lfs, it is hfs, and the directory was nothing but input. So under this I should have my file which I created today, and that was nothing but empty, right? empty.txt, where it is I just saw over here.
It's up. It's
Yeah,
up.
yeah, yeah. So if you see, we got this empty.txt file, and if you see, it has a byte size of 0. Okay, and again we'll try to see how to see this in human readable format. All those commands are little later, but we will try to go step by step. Okay, all basic commands are available, means most of the commands you will get. Now if you see, we were able to put the files to Hadoop file system. Now we will try to get those files from Hadoop file system to local file system or to the edge node. Okay, so now we created one file, empty file, right? So there is one command. Okay, so let's go. Okay, so there is one command that is nothing but get, or how we had copy from local, so we have copy to local. Okay, so the command would be same like how we have written earlier. So let's write, so HDFS, DFS, okay, get. From where you are getting the file. So what is the path? What is the source path? So that is nothing but I want to get the data from my Hadoop. So that is nothing at user, sef, HFS is the directory. Under that I have an input directory and I have created that empty.txt file. Okay, where I need to get to my current directory. You can write that, or else you can write your absolute path also. That is nothing but home, save, LFS and datasets. Okay, let's copy this piece of code or small line of code and let's execute this over here. Okay, so it is giving us nothing, so let's copy this. Let's go over here. Let's say hd, so not so ls -ltr and paste that. Okay, so empty.txt we are having, so but why we did not give that file name? So empty.txt. Okay, so I'm able to get that file. Similarly, you can do copy to local. Okay, so all are like very generic commands, and Linux flavor has been taken, and you will find it very easy to write all these HDFS commands. Okay, any questions? Someone was like,
Sir, sorry to interrupt.
no need to say sorry because I'm hearing that word again and again.
Yeah. So if you go back to the notepad,
Okay.
you have mentioned touch command in HDFS, right? That touch Z. So that commands basically creates an empty file.
Okay.
So do we have option to edit the file in HDFS directly?
No, that is a good question. So when it comes to HDFS file system, we cannot amend the data. We cannot update the data. Yeah, we can do override and we can do appending, but we cannot override the existing data. So update features are not available with Hadoop file system. Okay. Got it?
Yeah. Sorry. I was on mute.
Okay.
Yeah.
No issues. Thank you. And again, like no need to say sorry because there will be so many sorries till 4 months. Okay. So, okay. So now what we will do is we will see one more command as the question was asked. I don't know. Was it just tell your name so that I'll slowly recognizing your voice.
Vijay.
Vivek.
Vijay.
Sorry. Okay. So now we have created. So as he asked, will be able to update? As I told, no. Files will not be able to update, but yes, we can do append. Okay. Let's do that. Okay. So what I'll try to do, append to file. So we need to take care of like a camel case. Okay. So appends the contents of a given file to the source target file. So what we will do, it will append the data from wherever. So it appends the data from your source file to target file. Okay. Let's try to write a simple command. HDFS, DFS. The command is nothing but append to file. Okay. So this command is what? Append to file. So what we will do is let's take some file. Do we have some file for practice purpose? ls-ltr file to it's in zip format. So let's see any file. So let's say cards.csv or let's say employee1.txt. So it should have some small amount of data. Okay, cool. So what we will try to do is from your edge node, okay, home save LFS, the file under datasets folder. Okay, the file name is nothing but emp1.txt. What I am trying to do is from this path, what is my source path? Okay, I want to append the data to a particular file, and that file is available at my Hadoop. For that is user save HFS under input directory, and that file name was empty.txt. Let's copy this piece of code and let's hit this. Okay, and let's come a little back. So in place of append, we will try to write a cat command, and let's delete this and let's execute this piece. Okay, I'm trying to execute the same command again. I'm trying to execute the cat command again. Okay, so we are able to append the data or we are able to overwrite the data, but we will not be able to update the data. Okay, that's what we need to understand. For that, if you want to do that, then some you need to write a custom code in MapReduce. Okay, so we will not be playing with those things. So are we able to understand append to file?
Yes,
Small
sir.
small commands are there. Hopefully like all these are like you might be knowing, but I'm just running through because it just like few people might be new to this. We all know RM. Okay, so RM is nothing but to remove the files. Okay, so simply I can just remove file. So the file which we have created just now, hdfs dfs hyphen, so let's copy paste so that the time a small typo errors which I might make, that might be saved. So again I made, so what I need to do is hdfs dfs hyphen rm and the file name. Okay, so let's go over here. Even you can execute in the first terminal, or it's not necessary that you have to execute wherever, because on the edge node when you are trying to execute, they are getting executed to your Hadoop. Okay, if it says it is deleting my file. Okay, so basic commands with your hdfs, same flavor from your any of your Linux flavor. Okay, now we have we have like commands. Now few commands like sometimes we use. So one command is nothing but, let's say, count. Okay, okay, in this count, okay, we have like certain parameters, and that parameter is like in the human readable format. The other is in like verbose and something called hyphen q. Let me cross check. I'm not able to recall vividly. hdfs dfs. Okay, so hyphen help. Okay, and let's say I'm trying to grep, so count. Okay, so if you see wherever like count I was getting, so I'm trying to get that. Okay, so hyphen q is there, avish is there. So again, like they have not given the explanation what q, but I think like quota and the human readable format, that's what I'm able to recall. So let's see storage path it gives. Let's see what are the commands which gives us. Okay, so count the number of directories, files and bytes. Okay, so that could be in a human readable format, and the quota and the verbose method, which I'm able to recall because we don't use these commands frequently. Okay, so that's why like, so but just I am just trying to show all the commands which I am aware of. Okay, hdfs dfs. So let's say we are trying to count. Okay, so let's write all the parameters, hyphen h hyphen q, or let's go with one by one. How it looks like we'll come to know. Okay, so there is a file, and that file is nothing but movies.csv, right? We can make use of that file, movies.csv. Let's copy this piece of code and let's execute. Okay, so still I'm not able to identify what is 0, what is 1. Yeah, I can able to identify it's like a size of like 482.8 KB and at this path. So that is like in a human readable format, that is what it's telling. Let's see what is hyphen q is giving to us. Okay, so it is giving more information, but again like we don't know what is that more information. So again like some user, but again like if you need to know, no, but again like see it is giving a little more information. So it like hyphen v the verbose format. So if you see I was not able to identify what was none, so it is telling me quota, remaining quota, I don't know what is that, space quota, directory count 0. Okay, file count is this. Okay, so this is file count. Okay, so this is content size, so path name. Okay, so you can play with your hdfs command whenever you are getting, facing issues or not able to understand. Help is always the best place to get the command's description and the available arguments and flags which we can use with the commands which are provided by Hadoop. Okay, so this is like one of your Hadoop command. Then like we in Linux, like we have like disk usage. So similarly like here also it gives us, so like we have disk usage and the free disk. Okay, again like that is in a human readable format which I am able to recall. Okay, so let's take the same file and we'll try to execute the same command. The only thing what we need to change is we just need to say either it's a hyphen disk usage, or what you can say is like disk free. Okay, so let's go with the first one, that is nothing but disk usage. how much I have used. Let's execute this small statement. Okay, so and let's change to the free size again, like it is not giving me a good readable thing, but this is giving a little good readable. So if you see, this is telling me a clear way that this is my Hadoop file system on a port 9000. Okay, so I have assigned 60 GB. Okay, so let's come back. So it is telling me that size is available. I have used this much. Okay, so available is this much, and percentage in like percent, like it could be 0 point something, but that is okay. Okay, so same like how it gives on your Linux file system, the disk usage and the free, in a similar fashion we are able to see the same thing on my Hadoop file system. Okay, so that is nothing but disk free. So I hope like we are getting all these commands. Okay, basic commands, but you might be knowing everything, hopefully, but few people are new to this Hadoop, so it would be like new to them. Okay, but when it comes to Linux flavor, if they know, so again like they will also feel ease. Now we have seen copy from local. Similarly, we have move from local. You all know the difference from of copy and paste, right? Cut and paste and copy and paste. Okay, same as put. Okay, but what will happen except that source is deleted after it's copied. Okay, so what we can do is let's go quickly and let's take any file. So what I'll do is, let's say cpemp1.txt. So let's say to b7emp1.txt. Okay, so I'm just trying to, because I don't want to lose the data set. Okay, so let's say cat b6emp.txt. okay, so this was the file. Okay, so what we'll try to do, we'll try to push this and let's see whether it's getting deleted or not. Okay, so we know the command. So what is the command? hdfs dfs hyphen no copy from local. We are trying to do move from local. Okay, so what is the path? The home path, sorry, the edge node path is nothing but home safe. Under that we have created a folder that is nothing but LFS. Under that there is one more folder which we have created to keep our data sets, and under that we have a file name that is nothing but b6 whatever it is. Okay, then I'm trying to take this to my Hadoop cluster. So user safe, you will have to create this directory, you will have to create this directory, and I've already shown that. Let's copy this piece. Let's go over here and let's execute this. Okay, and let's verify that. So verify at both the places. We'll try to verify at both the places. So let's remove this, and the file name was nothing but b6emp1.txt. okay, we are able to see this. Okay, and let's come to your edge node. Let's try to do, yeah, even cat we do it will tell us the error, no such file or directory. Okay, so same like cut and paste, we have move and paste. Then if you want to do a copy within your Hadoop cluster, okay, so we were trying to do now from your edge node to your Hadoop cluster, but what if like within your Hadoop cluster if you want to do copy? So for that we have a simple command similar to your Linux, that is nothing but -cp. Okay, copies data within Hadoop cluster. Okay, so what will be the command? So simple, it will be hdfs dfs -cp. Okay, so what we will do is, let's copy this piece, control C, control V, the file name is nothing but this, and paste this. Okay, so let's copy the entire thing, and let's say I'm just trying to say, let's say 1. Okay, and let's copy this piece of code, clear off the screen, and let's execute this statement. Okay, and simply while we just try to do cat and 1, so we should be able to get that. Okay, same thing like if you want to do again like basic commands, simple commands, so I'm just making you familiar. So simply now how we did CP, so similarly what we can do is we can do MV also within your cluster. Okay, so let's do that. So move, what it will do, it will cut and paste. So in place of copy, it will copies the data within Hadoop cluster, but it will delete the source file or source copied file, whatever you want to write. Okay, so let's say MV. Okay, we already have this file, right? So let's say we'll take that and we'll change this to, let's say, 100, whatever. So let's copy this piece, let's execute this. So new file is created, but when we are trying to do 100, so that file should not be available. Oh, this file is, sorry. So the file like emp1, right? Because we copied from that. So that should throw an error. Okay, if you see, it is telling us because we copied, sorry, we did moved from this file. So that's why it was like cut and paste. Okay, if you remember like in your Linux, you try to provide some permissions. Okay, and the command to provide the permissions is nothing but chmod, change mode of your permissions. In a similar fashion, we can do that also over here. Okay, so let's see what is the permission of a particular file. So the file which we have created, so let's go top. So this is not available, but this is available. So let's go a little forward and let's try to do ls. Okay, so if you see, we all know like, so this hyphen stands for file, and if it's a D, that stands for a directory. Okay, so then like this 3, read, write, execute, then read, write, execute, and then read, write, execute. So the first one stands for user, the second one stands for group, and the third one stands for others. Okay, so let me copy this piece. Okay, so let's come so that the view is on the top. Okay, so if you try to do this, or it's better to copy this only so that you will have the reference. Okay, so see the first hyphen, it stands for, the significance of that is a file. If it would have been a D, so that would have been a directory. Okay, we all know this. Then the first 3 characters or first 3 places, so like I am having R, W and hyphen. Okay, so that signifies they are my user permissions. Then I have like R hyphen hyphen, that signifies they are my group permissions, if we belong to certain group or something. Okay, then I have R hyphen hyphen. Okay, so that is for others. So if you know like R stands for read, that's what we know, or that's what we know. Okay, and that has a octal representation and a character representation. So character representation is already there, it's R, but when it comes to octal representation, it has a significance as 4. Okay, similarly W stands for write. Okay, so a character representation is W. When it comes to octal representation, so it has a significance of 2. Then we have execute. Okay, so the character representation is X, which stands for execute, but it has a significance as 1. So these are like your permissions which you can make use of, and you can give all those things, but I'll just quickly write one syntax and you can play with it. Okay, so I'll not deep dive into all this. So hdfs dfs hyphen ls. Okay, so let's say the permissions which I want, no ls, so it is like chmod permissions which I need to provide. Okay, so now what I need to provide is let's say, so user is already having rw. Okay, so I want to add execute, so 4 plus 2 6, I need to add 1, so simply I will tell 7. So I don't want to give others read permissions also, and no permissions I want to give them. So let's go anything. So let's copy this piece of code and paste this, and let's execute this. Okay, and if you execute the earlier command, we had these permissions. Now let's see what are the permissions after assigning something. Okay, so you can play with your permissions similar to your Linux file system. Okay, so you can use octal method or you can use your character representation, so it will behave in a similar fashion. Okay, then we have one command, and sometimes this is useful when we are writing some scripts. Okay, that is a stat command. Okay, and that stat command has a lot of significant, means lot of arguments. So hdfs dfs hyphen help, and I need to grab my stat. Okay, so hyphen o. Okay, so it is giving me the only the word. I don't want the word. So let's call everything. I hope there should not be much. Okay, so if you see in the stat, stat is there, but there are no flags are available with this, which I am able to recall. Dun, 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 dun. But I am able to recall because see in this stat, like I can see like percent u user, because I have practiced this, so that's why I'm able to recall. And because I always tell this group, then user group, and then I think like percent b for block size. Then yeah, this is very important, percent r. Today we have seen in Hadoop 1.x and 2.x architecture the replication factor. So with percent r you can check that. Okay, and I think percent n, percent n stands for file name. That is what I am able to recall. We'll test it. So, and finally it's like percent y, small y or capital Y. Okay, so what does stat means? It will give you some statistics. Okay, so let's check some statistics. hdfs dfs, not hyphen ls, I would say stat. Okay, so what I will do is simply I will say percent u. Okay, so I think percent u, so which is the user, that's what I am able to recall. And let's copy the file. So let's copy this piece, and the file which we are playing with, that is nothing but movies.csv. Let's copy and let's execute this command. So we'll try to test all the, so okay, so I'm hopefully like my assumptions are correct. So user, okay, so after user, so we have seen which group he belongs to, so it should be root. Oh sorry, it's a super group. Okay, then we were seeing like user group, then we have block. B stands for block size. Okay, so whatever it's like in bytes, whatever the data it is there, so that is there. Then the important thing which I needed to show you is percent r, that is nothing but replication factor. Okay, so if you see, by default the replication factor is 1. We can change this replication factor in one of the hdfs site xml. Okay, now you will say, you said like the default factor, sorry, default replication factor is 3, but I'm able to see only here as 1. Okay, so the installation is done by me. Okay, so the configuration file are there. I have not, means like I have changed, I went to that configuration file and I have changed that, so that's why I'm able to see this. Okay, so with this you can see, and n is the file name, right? That's what I wanted to confirm. Yeah,
So,
movies.csv.
uh,
Yeah.
so Sai, this is when so this mission, this cluster is a single node cluster,
Yes,
right?
yes.
That's
It's
why
a
it is
single,
showing
yeah,
one.
it's a single node cluster. For that purpose, like the assignment is going to 1.
Okay.
Yeah. So if you see like if you just specify percent n, so you are getting a file name. Okay. So there are many options available, but again, like you can play with all these things and slowly you will, means like depending on the scenario and depending on the requirements, you should be able to get whatever the required information is. Okay. I showed you one help command, right? Now you have one command which gives you a usage also. Okay, which means that, let's say I don't know how to use this command. Okay, so what I can do is hdfs dfs, and I can just write usage, usag. Okay, and what is the command name? I think stat. Let me copy this piece, clear of the screen, and let's hit this. Okay, so I think that's hyphen is expecting. No. So HDFS, DFS, and the usage. Let's start. So let me try with the touch Z command. So it is asking touch and the path. Okay, it is expecting the path, but I want to get, okay, but what if I want to get the help of this individual command? Yeah, I'm getting. Okay. So let's change this stat. Now are we able to get something? Yeah. Okay, see, earlier I was not able to show you this with the grep command. Okay, if you see now, whatever information like I was talking about, so you can get all the information from here. Okay, so it gives you like with this HDFS DFS help and the command which we want to use, so it gives you the usage of that command. Okay, so that is what I wanted to show. So stats, it expects some format and the path of the file. It will give you certain explanation and the format which it is expecting in it. Okay, so you need to understand that and you need to provide as per that. Okay, so this is like one of your stat command. Okay, then a very important command when it comes to Hadoop and with the perspective of writing shell scripts, because we always write error handling parameters in our shell scripts. Okay, so what is that parameter? So that parameter is nothing but hyphen test. Okay, again it has a lot of parameters which I know. So check whether it's a directory, check whether the file is existing or not. Okay, if it is a file or not. Okay, if it is a non-zero byte file, that is S. If it is a 0 byte file, okay, then read write. Yeah, so hyphen read, then hyphen write. Okay, 0 byte I would. So these are like certain parameters which we can test. Okay, again if you are not sure, so simply you can write test. You should get all the parameters. Okay, so as I told you, hyphen D, it will tell me whether it's a directory or not. Hyphen E, it will tell me whether it's a file path exists or not. File is available, non-zero byte file, write permission. Sorry, I had write permission, read permission, and this is a 0 byte file size. Okay, so whenever we write the shell script, so we test certain paths. If it is file, do this. If it is a directory, do this. If it is a 0 byte file size, create this. If it is a non-zero byte file size, do this. So that's how like testing scenarios are being implemented in your scripts. Okay, so we'll check couple of commands and then later on you can explore. Okay, so let's go a little. So HDFS DFS hyphen ls. Okay, so if I just write user save, okay, if I write this, okay, so there are certain directories which are available to me. Okay, so like HFS. So if I go over here, okay, so let's start writing the syntaxes. HDFS DFS hyphen D. Okay, what I'm trying to do is I'm trying to, or before that I need to write the test. I cannot use direct argument or a flag, this path. Okay, so let's copy this and paste this. I did not copy it. Paste this. Okay, you are not getting an output. Why? Because you need to test that output with a $? If the exit command is 0, it means that that is a directory. Okay, otherwise if you just want to test it like negative, so let's test this. Still you are not getting an output, but if you just execute this, you can get an exit status of 1. So what we do is we write the if condition, we write the flagging conditions and we try to handle that with the return value parameter. If it is 0, which means that it is a directory, so then we'll write a certain condition. If it is 1, so maybe like I'll try to create that directory and then move ahead with my processing. Okay, so this is where you'll have to test all those things. Okay, so let's say now let's go to HFS directory. Okay, so under HFS, let's say input. Okay, and we have a file called movies.csv, right? It's not a directory, it's a file. Again, like if I try to execute, it should return me 1. But if I try to change that argument to -f, okay, so it should give me an exit status of 0. Okay, you need to play with all these commands. Again, if I just write -e, whether that file exists or not, again it will give me an exit status of 0. So let me clear off the screen. Exit status as 0. If I just try to let's say movies.csv1, okay, it is testing that. But again, if I'm just trying to play with it, again it is telling me. So you need to play with all these arguments and flags which are being given to us with this command, which is nothing but test. Again, if it comes to let's say testing the 0 bytes, so -s is a non-zero byte size, so it should give me a, because it is like your non-zero byte, which is that. So you have to play with all these specific commands. Okay. So that is one test command which I am able to recall, and I think like there are few commands. So one like find command. Okay, so let's check the find command. Okay, so when it comes to find, same like Linux, we have find command. Okay, so what it does is it finds the file that matches the expression and applies a selection. So it has again like, so what you can do is you can write the flagging parameter or argument as -name, or you can ignore the name, sorry, you can ignore the case sensitive also with -i flag. Okay, so that's what like it does. So what we will do is simply like we had this, right? So I'll just quickly copy this as is. Okay, let's come back over here and let's paste this, and we'll change this command. Okay, so what we'll try to write -find. Yeah, looks good to me. Let's see what it gives me to. Okay, so it is able to find, let's say, okay, so it is not available. Then let's say if I'm trying to remove this, but when I'm trying to write movies, but I want to ignore my alt back, I need to ignore my case sensitive. Okay. So I think the echo $question, it is available. Okay, so you can ignore the case sensitive with the hyphen flag. Okay, so it just like if you want to find it, so the same like command file, there is one more command like get access control light and access control list, get AFCL. Okay, so you might be knowing this. So get files ACL. So I remember like that. So, okay, so it is nothing but it displays you the access control list. That's what it does. Okay, so what we will do is HDFS DFS hyphen get access control list. Okay, now from where we need to get, so let's say the path is nothing but user save Hadoop file system, then we have input. Okay, and in this there is, yeah, we can take this control lights and whatever the directory, let's see, we can do the recursive method also. First let's test. Okay, so if you see for this, what are the permissions of this, but if you see under my input directory, so there are lots of files available. Okay, so if you want to do that recursively, so you just have to press R. So it will give you the entire, like whatever the list, whatever subdirectories files are available, it will give you each and every file's subdirectories access control list. Okay, sometimes it becomes important to play with this access control rights, because it gives you a flexibility to check the file permissions, because sometimes we need to give few permissions to someone and few permissions to others. That's why it becomes a little important. Okay, then a couple of commands. So we are almost in closing phase, so don't get bored. Okay, then we have a hyphen text command. Okay, we all know what is a cat command. Cat displays the data, right? So this text command, it displays gzip करना पड़ेगा, yeah, so it displays zipped data. So it displays zipped file data, to be precise. Okay, which cannot be seen by cat command. Okay, so let's write a small for that. For first we'll have to zip it ls. So the file which we created was b6, right? So zip, copy paste it. So let's go with emp1.txt. Okay, gzip I think. Okay, so ls hyphen ltr, let's say emp2.txt. I'll have to do zcat, because if I do cat it will not work. If I do zcat on emp2.txt, it should be able to work. Okay, so all these are like tarring, untarring, zipping, unzipping. So this file now, if you see, it's in zip format. So first what I will do, it's available on my edge node. First I will push this file to my Hadoop file system, hdfs dfs -ls. So what is my path? Home, safe. Under that we created a folder of LFS and data sets. Okay, and then we created we already have a file that is nothing but this. I need to push this at user safe. Okay, then Hadoop file system, then input, and this is fine for me. Let's copy this piece, clear of the screen.
So if you have to use
Yeah,
copy from local.
sorry, I recognize that. So either we can write put or copy from local. Okay, so let me make that change here also, so that if I give you, so copy from local. Okay, so it is done. Now let's go to this path. Okay, and hdfs, sorry, let's write it over here so that you will also have this hdfs dfs. Okay, when I'm trying to do cat to this location, and the file name is nothing but emp2.txt.gz. okay, gz. Let's copy this and execute this. Okay, so it is giving me some junk data. Okay, if you want to see this junk data, so you need to execute your text command. That is like what I was trying to say. Okay, so this is one command we again use, because sometimes if we get binary data, so not all binary formats will be able to see, but few are available for us. Okay, so these are like 20 commands which you, again, like not all you might be using, but these are some commands which and one command purposely I do not show in every batch, that is get merge command. Okay, so I always give this command as an assignment. I'll just give you a hint. What it will do, it will just, let's say if you want to merge, let's say there are 3 files available in Hadoop, f1, f2, f3. I want to merge the data from all these 3 files and bring the data to my local. So this command will help you. Okay, so I always give this assignment to my batch, so I'll be following these things. Okay, so this is like all my 21 commands which are there, so which I was able to recall slowly and slowly. So hopefully like people are coming from Unix flavor, so they should be able to relate this. But again, like even if people are new, so I will be sharing the recording, I will be sharing this notepad, and you can go through each and every command, practice it, and do R&D, whatever you want to. You can play with machine. Okay, no restrictions. So I'll stop for today, and